Hey guys, hello and welcome. And today we will talk about solar panel. In Rajasthan, Jodhpur district lies the village Bhadla. If you go there, you will see it gets very hot here. During the summer days, the temperature here reach around 46 degree to 48 degree. More than our normal temperature is we can bear we can sweet it. It's very much suitable for human is in between 25 to 35, but after that in heat we can't bear that. So there are several sandstorm as well. If you look at this area from the satellite, it looks somewhat like this is in 2015-16, but if you look at the present days the satellite image of it, this will what you will see. A solar energy is growing at the rapid pace and across the whole world. It has turned out to be the cheapest form of energy today. But have you ever thought what would happen if we cover all the deserts of all the worlds with solar power plants? Like, if we cover the whole world, can it meet that energy? So, can it power the whole world? If yes, then how? And if no, then what are the pros, like what are the possibilities of solar energy? So, Badal Solar Park, friends, did you know that this is the biggest solar park in the world and spread across an area of 14,000 acres of land? In terms of kilometers, the land measures around 56.6 meters kilometer square. So solar panel have been installed here when you zoom out of the satellite view. So it have the Badal solar is like the in Rajasthan, it is approx 56.6 kilometers square. And if you zoom in the satellite, you will truly realize, you will see that satellite in the satellite image, you will see the solar panel in the big, all you can see it. So when you zoom out the satellite view, you will truly realize that how huge it is, and it can fit half of the city of Paris. Like, it is the half of the Paris city, and it has a total capacity of 2245 megawatt of energy. This single solar park can produce enough electricity to meet the electricity requirement of city of Kolkata. This the city of joy. We spend like whatever our spending energy requirement we can fulfill with only this Badal solar power plant. It is generating 2245 megawatts, so we can power a whole city. So can you imagine that? This huge solar power plant shows you the true potential of a solar energy. Internationally, Morocco is considered to be the world leader in terms of solar energy. I have already tried and talked with some private solar system provider, and most of them don't provide on-grid solar panels. And like someone was asking me, like this is so much opportunities there, right? So like why not we can produce, like we can a guy from West Bengal actually, he wants to install his panel in his home. So he says like most of them don't provide on grid solar system. So there are two type of solar system, one grid and also your single, like you can install in your home, so it is not connected to the grid. So one is the but no one provide that solar grid panels and battery system. Like you have to use the battery if you do the your for single use for your residence. So battery system panel cost too much, and the battery life is only for 5 years approx. So that is the drawback also is there, and most of them disburse less government subsidies. We will talk about the subsidies also. So sometimes don't like disburse those subsidies to the end users. Like government is providing the subsidies, and we'll talk it later. And they will only tell you how to procure permissions for the on-grid solar system, but CSC will not give it easily. They will waste much of your time. So sad reality of solar in West Bengal actually. Anyway, like I'm from Bengal, so that is what I'm telling you. But come to the point. So power is the root income actually in West Bengal. That is what their main income. So it's allied company, and like they are earning a huge amount from this power generation. So they don't like if you install your solar in your home, so you're not going to use their power meter, right? You're not going to use their power, you will not consume their energy, so it will like they are losing the customers, so nobody will give up their profits. So that is why you are facing this kind of problem, brother. And anyway, like, so come to the point, like 20% of the electricity produced in the country come from the solar energy. So what is the percentage? Like 20% of the electricity produced in the country in India, okay, is coming from the solar panel. Like one of few of my friends who work in solar grid actually in Andhra and many other places, like company or like installing 100 miles and kilometers of solar panel, and they are like almost 20% of the country's demand we are fulfilling. So, and the world largest concentrated solar power plant can be found in Morocco. Okay, that is what, like in Morocco, that is going on. So concentrated refer to the solar power plants that generate heat from the sunlight by concentrating it at one spot. Like concentrating, I'm talking about that kind of stuff in this tube that you see in front of the panel, and later the thermal energy is used to produce electricity. On the other hand, the normal solar panel are photovoltaic solar panel, and like the ones installed in Rajasthan, that is what we are talking about. That is a photovoltaic solar panel, and they directly convert sunlight into electrical charges. So, but this raise an interesting questions. How big can we scale those giant solar projects? This is a massive project, right? So can we cover the entire desert with solar panel? And what will happen if we convert the Sahara desert with solar panel? Can the global electricity demand be met slowly and solar panel? Okay. So before we talk about, I'm going to give you some brief informations how this solar panel work, right? So the Earth intercepts a lot of solar power in like 173,000 terawatts. So the Earth interrupt this, like this amount of this thousand terawatt of earth, like sunlight is coming, so that's the 10,000 time more power than the planet's population use. And so it is possible that one day the world could be completely reliant on solar energy. And to answer that questions, we first need to examine how solar panel converts solar energy from sunlight. This is our sun, and this is your solar rooftop in the earth, right? These have a few silicon and all, and it is connected with the battery. Now how this is converting? So the questions, first we need to examine how solar panel converts solar energy into electrical energy. Now solar panels are made of some small unit called solar cell. So this is our cell, and the most common solar cell are made from silicon, and silicon is have a like, yeah, silicon.
Silicon is a
What?
solar system panel.
No, 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 no. Silicon is a material, man. Silicon is a ingredient that is required. A semiconductor that is the second most abundant element on the earth and in a solar cell. Now, crystalline silicon is sandwiched between conductive layers, and each silicon atom is connected to its neighbors by four strong bonds. You know, the if you see the silicon atom, it have four extra electrons, okay, and so that is we can create a four bonds with others. Okay, if you see in the science classes, if you study them, you will found them. So that each silicon atom is connected to its neighbor by four silicon atoms. Like this is also a silicon, right? And this is also connected with them. Okay, this is also connected, this is connected, like same way, all are connected. Okay, now so which keep the electrons in place so no current can flow. So that is what in the normal cases. But here is the key: a silicon solar cell use two different layer of silicons. So and one is n type, another one is one n type, one is n type, another is p type. You know, we study in our engineering classes, we do the doping actually. So n type and p type doping. So we'll like, this is very easy. So the thing is that, so in n type silicon, that have a electron, extra electrons. So if it is a n type silicon, we do a doping, we ingredient a material that is like lead, so that have a 5 electrons, okay, and this silicon have a 4.
Hmm.
So 4 is bonding with the 4 and the rest 1 is remaining, right?
Hmm.
So that 1 extra electrons. But in case of p, we use that material that have a 3 electrons. We do
Three.
the doping. So 4 is connected with 1, with 3, like, and 1 is remaining, so that is we call as a whole. So there are two type of silicon mates. So electrons can wander across the p-n junction. Okay, so if you see, this is your p type and n type, and this is your p-n junction. This is p doping, this is n doping. So level and leaving a positive charge on one side and creating a negative charge on the other side. For example, in the p for positive and n for negative. So you see this positive and negative is started. So a current can flow from these directions. Okay, so you will see in the animations, you will learn it more better way. You can visualize it in the, like, in the molecule levels what is going on. So you can think of a light as the flow of tiny particles called photons. So smoothing out from the sun, when one of those photons strike the silicon cell with enough energy, it can knock an electrons from its bond. So one photon hit, so one electron start release from the silicon, and that is what the bias create, that voltage balance is like disbalance. So always it want to be a neutralized form. So one extra electron is like produced, so that will start flow from one direction to another direction. That is what the electrical flow will occur, and then you will see the charging, it's charging.
Positive
So right,
charge.
yes. So the silicon cell with enough energy, and it can knock an electron from its bond and leaving a hole. And the negatively charged electron and the locations of the positively
Positively
charged
charged
hole
hole.
are now free to move around. So, but because of the electric field at the p-n junctions, they only go one way.
One
They
way.
can only go
One
one way,
way.
not the two way. Like you can't say
Not
like
that two
positive
way,
is going
one way.
negative and negative is going positive. No, that is not
Uh,
possible. So while the electron is drawn in the n side, while the hole is drawn in the p
P
side,
side.
the mobile electrons are collected by
Collected by
thin
thin
metal
metal finger.
finger at the top of the cell. So from there, the flow through an external circuit
Circuit.
doing electrical work, like preparing a light bulb. So before returning through the conductive aluminum sheet on the back, each silicon cell only puts out a half a volt. Each silicon cell only put out half volt.
Half bowl.
Yes, half volt. And you can straight them together in model to get more power. So 12 photoelectric cell are enough to charge a cell phone. How many? You can have a 12 photoelectric cell, one cell now.
One
One
cell.
cell, this is, you need approx 12 cell to charge a cell phone battery. This is your cell phone battery, right? So you can charge your cell phone battery.
Right.
Right. So while it take many models to power the entire house, electrons are the only moving parts in the solar cell. What is moving part? Electron. So you will study in the physics that how electron moves from n type to p type, how we do the doping, and how, what is happening here. So that is quite easy, and they all go back whether they come from. So they come from one way and they go in the end other way. So you use your bulb, for example, this is your bulb, right? And you connected it in this circuit, and this is
Right.
what the electron will come flow and from the light, and that will end up in the next terminal. So they are the, okay, so solar cell can last for a decades. So there is nothing to get worn out or use up. So solar cell can last for decades. So what's the stopping us from being completely reliant on solar power? Why we are
Solar
still
power.
not using it? So there are political factors, my dear.
Okay.
Yes, scientists already invented. Scientists invented atom bomb.
Atom.
They never said us to drop it from in Japan. They no, it's a politicians. They did it. They misuse the science power. Same way, still we are. They are misusing the invention of science. Like what can do for like humanity. So there are political factors at play. Not to mention business that lobby to maintain the status quo. But for now, let's focus on the physical and logistical
Mechanical
challenges.
challenge. Physical and logical challenge.
Logistical. The most obvious of those is that solar energy is unevenly distributed across the planet, and some areas are
Then
shining
others.
than others. Yeah, some light, some area with in the light come more, some area is not. Like in the north and south pole you will not see that much light there. So it is also inconsistent. Less solar energy is available on cloudy days or at night.
No.
So a total reliance would require efficient way to get electricity from sunny spot to
Cloud
cloudy
one.
ones, right? So we use in the deserts, we prefer deserts for sunlights, right? So deserts or that middle middle of the
Middle
earth,
area.
right? Like center of the earth.
Yes.
Yes,
Central of
that is
the
a there we have a more like lights is there now.
lights.
Yeah. So a total reliance would require efficient way to get electricity from sunny spot to cloudy one, and the effective storage of energy that is efficient of all the cell itself is a challenge too. So if sunlight is reflected instead of absorbed, or it dislodged, electrons fall back into the hole before going through the circuit, that photons energy is lost.
Lost.
So the most efficient solar cell yet still convey 46%. How much? 46% efficiency.
46%.
Right. So efficiency is 46%. Available sunlight on to electricity.
To electricity.
And most commercial systems are currently at 15 to 20% efficiency.
Efficient.
Right. So in spirit of those limitations, it actually would be possible to power the entire world with today's solar technology. We need the funding to build the infrastructure. Yes, who will pay those huge amount of money for this infrastructure, for this like generating this silicon and cell and producing the solar cell and installing them? And there is a political issue, as I told you, right? So we need to fund those building infrastructure and also a good deal of space. So estimate range from 10 to hundreds of thousands of square miles, which seems like a lot, but the Sahara desert alone is cover like 3 million square area. Sahara desert alone is 3 million square area, so we can cover, right? No one is like, it is inhabitable, right? So we can use those inhabitable land to produce and generate electricity from solar power, from solar energy. Why not we are using it? So meanwhile solar cells are getting better and cheaper, because there are lots of research and invention is going on. Like people are doing, working day and night to make it more better and efficient solar energy, solar cell, right? And also we also increase like our battery capacity power. Like we are also increasing our grid systems. So future is, we are very much hopeful. So and are competing with the electricity from the grid. Also we have to compete. So and innovations like floating solar farms, like in also we are also, we can also use like this this
Sun.
I'm sorry, sea, like sea is open sea, right? We can use that floating solar cell nowadays. Like it's very much common, people are using it. So like floating solar farm and may change the land space entirely. So though experimental aside, there is the fact that over a million over a billion people
Billion
don't
people.
have access to a terrible electricity grid, right? So still in this earth there are people who are living without electricity because
Yes.
grid is not reached that level. Okay,
Yes.
so what they are doing, like in people are in jungle. Okay, there is no electricity, no pole, nothing is there. So how will you use that electricity? You have a phone, right? You have to charge it. You need energy. So at that time people are using, and those locations and those areas
Those
people are
location.
using more solar energy, solar power, solar panels,
Right.
especially in the developing countries, many of which are sunny. So in people like that, solar energy is already much cheaper and safer than available alternatives like kerosene and petrol and others. So
Correct.
for say Finland and Seattle, though effective solar energy may still be a little way off, we need less of this and more of this. The solar energy is like to account for 60% of the global renewable power goals in
Goals in
2020. Like,
22.
so we have a 60, we want to go 60% by
60%.
2022. It's already
2022.
2022. We can fly an airplanes entirely solar powered. We can fly, yes we can.
Yes, yes, yes.
Yes, there is few planes. So with
Okay.
solar power panel, planes in orbit, like panels in orbit, will be able to provide energy day and nights,
Day and
all
night.
day long, no
Okay.
matter what the weather is like. And it's
Okay.
quite interesting actually, friends. Speaking realistically, to meet the global electricity requirement, we wouldn't even need to completely cover the Sahara desert. The
The
solar
solar
panel,
panel.
so much solar energy reach the earth that it's unimaginable. I'm telling you, in fact, that at all times, like 1000, like 1,73,000 terawatts, as I told you earlier, of solar energy reach the earth. So this is more than 10,000 times. This is more than 10,000 time global electricity requirement.
Requirement.
Okay.
Okay.
So it is estimated that the sunlight reach the earth is in 1.5 hours
Hours.
and can meet the annual global energy consumption. मतलब भाई 1.5 घंटा अगर सनलाइट को हम एनर्जी में कन्वर्ट कर दिया तो हमें और साल भर एनर्जी चाहिए ही नहीं.
हाँ.
फिर क्या चुतियापा कर रहे हैं हम लोग. So it means that even if solar panels are installed in a relatively some smaller area in the earth, so it can meet the global requirement. So how small can the area be? How much sorry, how much of the lands need to be covered with solar panels? It was estimated by Nandini May in her research thesis in 2005. One girl, she was doing a research, and she published a journal, and she said that if you zoom in on North Africa in the small area despite by the red squares, so by installing solar panels here, the electricity requirement of Europe can be met. And in a slight larger square, those sites of 254 kilometers solar panel installed here would be enough to meet the global electricity requirement. Isn't mind blowing? Yes, it is.
Mind blowing.
It's mind blowing. So, but the estimate is not a bit of outdated. It's a bit of outdated. It was done in 2005. Now we can, like, population has been increased. For example, whatever estimations they gave, we can recalculate it, and that it's still pretty much doable. So since then, the global demand has raised significantly, and a better and more realistic estimation was been published that look like this. You can find it on land generator, a land
Generator.
land art generator.org. You can go and find it. land land art generator, so dot
Land
org.
generator.
You can go and find,
Organization.
you can find on this website. So here it is assumed that the efficiency of the solar panel would be 20%, and in those estimate the solar panels are not installed in only one part of the earth, for example in desert like Sahara. So then we have to do that, like transmission cost will be higher, you know, we have to do the grid, right? We have to send it through the grid, the electricity. So best is we can, the whatever the city is nearby city, or we can place it in different places, right? So you
Right.
can see the multiple square in various part of the world, and they have been fairly distributed, and claiming that in if solar power plants are installed in those squares, the global requirement can be met. And other assumptions while calculating those, the exact calculations, if you want to know those, I have put the link in the websites in the description below, and go and check it out. But bottom line
But the bottom line,
is, wow, we need about 500,000 kilometer square land. How many? The area should be 500,000 square, like kilometer square. Okay? So
Okay.
this much land we require in on the earth, and we'll have to install solar panel in those areas to meet the global energy demand. And like this 500,000 kilometer may sounds like a big area, but don't forget that the world's biggest solar power plant in Rajasthan, and that I shown you at the beginning of this video. So span around 56,000 kilometer square. So no, now with this Balda, the Rajasthan solar panel is only how much? 50,
56.
it's only
kilometer
56
square.
kilometer square. Yes. And so with this 56 kilometer square, we are like 9,000 more such we require. How many? We require 9,000 more such solar power plants across the world. In around the world we need more, like 9,000 solar plants install in every city, like do this in every desert. Okay.
Every day.
So like, and so much solar power plants, like 9,000 or more such power plants across the world we would be done. And India's peak electricity demand as of this 2022 June was at the record highest at how much? 2,000. Like what is the India's demand in electricity? India's demand is 2,10,793 megawatts. 2,10,793 megawatts electricity consumption, like is India's demand now. So and the Bhadla solar power plant can produce more than how much? 2,000 megawatt. So if we set up like 100, if we talk about the India, so we can set up like 100 such solar power plants in India, and we can meet the electricity demand of our country. So how much we need? We require, we need only 100, man.
100.
Right? So each power plant is producing 2,000 megawatts. Our India's peak demand is 2 lakhs. If we multiply with the 100, like 2 lakhs, we will meet that demand. Right? So we can meet that electricity demand of our country, and slowly, and by using solar energy. Coming back to the global estimations that 500,000 kilometers estimated, there are some interesting consumption comparison. That total area of the highways in America is 94,000. See, what is the like global demand? Global demand is, where is that? Uh, okay. So like it is like 20% of 500,000 kilometers, right? 500,000 kilometers, it is about 20%. And if you go in America, the American highways, like it is 20% of the global energy consumption. America accounts for 20% of the global energy consumptions. It means that the resources spent by America to lay the roads of the vehicle, if solar plants are installed in all in an area of equal size, American electricity demand can be met slowly and by solar energy. So whatever the roads we have in America, na, what you have to do? we have to go and install all the solar panels on
Solar
the top,
panels in the top.
right?
You are
And
right.
like we'll solve this energy problem, like we'll meet the energy demand of America. That is so
America.
simple.
Solar energy.
So there, that is an interesting comparisons involved in this golf course also. So the size of a typical golf course is 1 square kilometer. How much? One
kilometer
kilometer
is
square.
square.
Yes, 1 kilometer square or 1 square kilometer.
Uh, 1 square kilometer.
Yes.
Right.
So there are about 400,000 golf courses around the world. How much? 440,000 golf courses, and each is 1 kilometer square. So right. So if we frame all our set of setups instead of the golf courses, it will account for 10% of the land, 10% of the land requirement, obviously. And that this plan sounds wonderful, but it is so good. Why are not government across the world executing it? Because friend, we have, when we think about it practically, many of more problem comes. So first and foremost is the geopolitics, as I told you, that politicians. So if solar panels are installed in the countries in the Sahara Desert, so other countries will need to be depend on it, and those countries will gain immense power. So no other country will want that. And anyhow, history is full of wars fought for energy like oils. You know what is going on in Iran, in Iraq,
Iran,
huh?
Iran,
In
Iraq.
these Middle East countries. Why they are fighting? Because of this oil. This oil. What is oil? Oil is nothing but
Venice
energy. Yes. So they are they fought lots of war for energy. So no Americans, no governments, no politicians wants that only this Sahara desert should cover with a solar panel, because all the control will come over to India. No one wants. So like we can distribute it anyway. So similar to how oil is produced only in a few countries, if the same happen with the solar energy as well, the same problem will be created again. So then the second problem will be distributing the energy. Suppose we build a huge solar power plants in the Sahara deserts or in the multiple places across the world, taking the electricity to even every part of the world. So would need a lot of money, right?
Right.
And electricity, and it will create a lot of wastage too. When we transmit through our electric grid, and it's like we increase step up using transformer and then step down it, and this process occur a lots of losses. So there is a lots of loss will occur. So the third problem will be maintenance. Who will maintain those solar panels? You know what? So the solar panels require regular cleaning. We have to go and clean regularly because the dust will come on the top of the solar. So the require regular cleaning, especially in the if they are installed in the deserts or in the snow area. So for like frequently sandstorm and all is like cover the solar cell. So you have to clean it, right? Who will pay? Like there is few futuristic stuff also, like a cleaning robot is there. So when the sand accumulates on the solar plant panels, they do not work as well. So you will wonder how the Bhadla solar power plant deals with those problems. So friend, more than 2000 cleaning robots have been set up there, and we have been set up there, and we have solutions, but this need to be work on some more. After this, the next biggest problem would be the life cycle. Once installed, like if you once you install that one solar panel in the desert area, and its life cycle is approx 25 years. So we'll get electricity energy for like 25 years, and before have before having to replace them, a lot of resources and funds will be spent on it. And while we are talking about this money, and one of the biggest problem is money itself. So why don't we set up 100 solar power plants similar to Badal solar power plants? Because we don't have that much fund to do to, and where we will get those money from? Right? So there are so many problems we have to encounter one by one, but we are very much futuristic. We are hopeful, but there are the solutions of those problems. So the there indeed is a solutions. Perhaps the biggest solutions that we can see is to stop imagine the enormous solar power plant and start imagining solar energy on an individual level. We can do it in an individual level, right? So most of the problem that we encounter at a bigger scale are irrelevant on an individual level. So if people start installing solar panels in their homes, for example, in the grid we have to do this massive installation, right? So in if you are living in your home, okay, so we can install a small stuff and that will give you the power, right? In an individual level that can be very much possible. Yeah, for that we may be like it's maybe more costly, and also you have to install the batteries and you have to store it, right? In so right, so are irrelevant on an individual level. So if people start installing solar panel in their home, and geopolitical will not be a problem, maintenance will be an easy and individual level. The solar panel company will provide maintenance and energy. People are doing it in an individual level, actually, those who have money though, and government also giving the subsidy. So energy distribution will not be a problem because people will see the electricity in their home first, and then think about distributing the surplus. And there and in term of cost it will benefit everyone. Today there is a no cheaper alternative than rooftop solar electricity, and it doesn't matter in which state you live in. If you have a space to install a solar panel on your rooftop, it will be very like beneficial to you. Friends, individual solar systems are of two types. One is grid and off grid. So on grid means that the solar system that you install at your home will be connected to the grid, and there you will get the facility to net metering. Actually, what net metering is meaning, like during the day the electricity produced by your solar panel will first power your house, and if there is any surplus or extra power you generate, it will be transmitted to the grid so that it could be used by other. And at night when the solar panel do not produce electricity, you use the electricity from the grid, and you will have to pay for the electricity that you use from the grid, and you will get paid for the electricity that you transmitted to the grid. That is also like, for example, like you generate 100 for example in the at night, like in day you generated 10 watt. 10 watt is, for example, 10 or 100 watts of electricity, and in the total in the day, like you use in the day is like 40. So like 60 is remaining, is will go in the surplus will go to the grid. Okay, that will be counted in the meter, in that energy meter. And at night you require like like more 50, so you will again consume 50, so 10 is your surplus. For example, someday you may require more. Okay, for example, you produce at day you produce only 50, and at night you like at day you are using 40, and at night you are using 60. So the 10 unit extra you require, right? So that will come from the grid, and in the grid then you have to pay for the 10 rupees, and whatever you send it to the grid they will pay you, or at the end they like minimize, like they will pay and you will get, so it will equal almost. So and you will get paid for the electricity, and at the net you will net of the two will be electrical bills. So this is known as the net metering. What is this? This is as a net metering. The second option is off grid system. No, you no need to connect with the grid. Whatever you will produce you have to store and you have to use. So it means that you do not connect your solar system to the grid. You are not connected to the grid. Instead, you are connected it to the battery. When there is no solar energy at night, the energy stored in the battery will be used to meet the electricity requirement at night. The problem here is that the cost of the battery is often very high. That is why on-grid solar system is more beneficial. And as I told you, the average life cycle of a solar system is 25 years, and from the perspective of an individual, it is one-time investment. Like you have to spend while you are doing installation now, you have to spend one-time investment like 10, 20, 1 lakh, somewhat amount of you require based on your area. And eventually there will be a break even point for the investments and that can be somewhat like you have to invest for these 3 to 5 years. After 3 to 5 years, whatever you will get from this solar panel, this will be your profit. So the first 2 3 to 5 years you need to invest, and then you will start getting the return from and the 5 to 25 years to get undoubted net profit. So specifically talking about India, there are additional benefits. There are subsidies. You know what? Indian government, they are giving subsidies. Like they are giving subsidies and up to how much? 94,000 rupees for installing solar panels in your home. If after hearing this, you too are interested, okay, you can go and check it out. And like there is many other third parties, you can go and ask, check it. Okay, they will do it for you, like they will do maintenance and they will do the installation and also help you to get the money from the government, like the subsidies. So yes, if you are taking interest in solar panel in the home for the next level, so what's stopping you? Look at those structures, they are known, like those are the known as heliotropic. So I will tell you one story, like one, it is not a story, it is real, that one of German architect, okay, the first he built a first house. The first such house was built in Freiburg, Germany in 1994, and this looked like a futuristic concept. It is a house that is completely self solar power, only solar power. It is not connected to the grid. And the German architect and the environmental activist Rolf Disch built this first house, and the cylindrical shape of that you see is serve a major purpose. And during the winter, the window of the house face the sun, and so that more heat can be absorbed and the house can be kept warm. The back is highly insulated. In the summer, the sun shine at the back so that the house can be kept cool. This reduces the cost to keep the house warm or cool. Additionally, the solar panel are installed on the roof, so which meet the energy equipment of the houses. So those solar panels rotate independently. They follow the sun throughout the days and pointing towards it, so that the energy productions is at the maximum level, even though the hot weather even though the hot water in the house is providing through vacuum tube solar panel. You know what vacuum tube solar panel? I was in Bangalore. I saw so many vacuum tube solar panels, that is for water boiler, right? For water heater. And the design of the building is the most energy efficient in the world, and such a house produce 5 to 6 times the energy that is consumed. The architect call it is plus energy, and this completely emission free, like CO2 and CO2 natural, and it is 100% regenerative. Since then, more such heliotropic houses have been built, and the phenomena is known as heliotropism, and we can spot this in the nature as well. The sunflower, you see the sunflower, right? So they always face to the sun. They bloom during the day and the petals close at night. Similarly, similar to how those flowers work, they do this exactly same. So do those house. Overall, there is a lot of potential in the solar energy. Even if we talk at that individual level, the best solution is not to have individual install solar panels in their homes, and we stop creating solar parks or having solar parks only without individual setups. Considering the locations, the funds available, and the needs, we need to have a combinations of both. I have sang a lot of parises of solar energy in this video. So let me show you the other side of this. Solar energy isn't some magic that can solve all problems. So we talk all the good things. Now this is time to talk about the negative things. Solar energy isn't the magic that can solve all the problems. There are several drawbacks and the shortcomings also. The drawbacks are not that one that you are probably thinking about. The biggest disadvantages of solar energy that people consider is when it's cloudy or during the winter. During the winter, right? It is not that disadvantage. People think that the solar energy wouldn't work as well. So this is a myth actually. So you would see that if during the summer, like it is like
Six
in summer
unit.
it's 6 unit per kilowatt, okay, per day is produced. But in 3 units, like it will produce in the monsoon area. For example, it's a rainy day. In monsoon it is produced like 3 unit, and in the winter time, it produce 4 units per kilowatts. So though there are the slight differences and it isn't significant, sorry, because the concept of photovoltaic depends on the light. As long as there is a sufficient light around it, irrespective of any rain or cloud, they will keep working. So this is why it may could place you and will still see solar panels in northern Europe countries. Many houses have solar panels even though it is very cold there, because as long as their light, there is light, so they will work. So if this wasn't disadvantages, and what is it? So what is the disadvantages? The first is the carbon emission. This is because most of the solar cell is made of a silicon, right? And as I already told you that silicon is very much common, and silicon and glasses are common. Additional materials such as silver, copper, indium and palladium are used in solar panels. So those materials need to be extracted to manufacture the solar panels, and this has a huge environmental cost. Collecting silicons and glasses isn't problematic because it's available in the sand,
Right.
right? They are found everywhere and are non-toxic also. But the metal that I mentioned, silver, copper and other materials, need to be mined, and that mining lead to the soil, water and air pollutions. The greenhouse gas emissions are increased, and the entire process of manufactures solar panels are in the factories and produce its own set of carbon emissions. Obviously you need to consider those, like if you compare these with the fossil fuels like coal, gas and oil, and compare them with the using the solar energy, is better, definitely better. So oil and other natural resources are more carbon emissive, okay, they are more harmful for environment. As like solar panel also harmful at a time, right? You have to do this one time, you have to bear this one time cost. Like, but as compared to oil and natural gases, solar is more better. But the point is that it is not that solar energy has zero impact on the environment. It is estimated that the carbon output of the solar energy and the solar panel is 20 times lower. How much? It is 20 times lower.
20 times.
Yeah, the second biggest disadvantage is that that the life cycle of a solar panel that happen when the life cycle of a solar energy runs out. You would consider simply replacing them, but what happened to the old solar panels? Can that be recycled? Yeah, that is what we have to think about, that recycling the old solar panels. So today it isn't very economically profitable to recycle the solar panels. So that is what we have to use for pump and dump. So well, now we haven't needed to recycle solar panel much because the solar panel installed in the 1970s are still working. Their efficiency has dropped 50 years later, but they can still be used. But there will be a point in the future where a lot of solar panels will be needed to be replaced. So those are a few of the things will have to be considered towards in the futures. But the future of the solar energy is very bright. Each year, the cost of a production solar panel is going down because of the huge and massive productions, and new technologies and innovations are seen. The efficiency of solar panel is increased. People are coming up with the more creative ways to generate solar energy, not only on land or in houses, even on water bodies. You can find floating solar panels and plants in Kerala, and such solar panel plants, solar,
Solar power plant.
yes, it is floating solar
Kerala.
power in Kerala, right? Such solar panels are used in the Maldives, Maldives as well. So to power tourist resorts, those have been introduced in the transport sections as well. Perhaps having solar panels on vehicles may not seem as interesting to you, but boats and aeroplanes with the solar panels are also being tested, like the Sun 21 solar boat holds the Guinness World Record and crossed the Atlantic Ocean in the shortest durations using that solar energy. Solar Impulse is Solar Impulse 2 is also one of the aeroplane. It is an aircraft with the 17,000, how much, 17,000 solar cell on its wings. So the plane flew 40,000, that plane flew how much, 40,000 kilometers without any fuel. You see how futuristic it is, and going into the future with those creative ideas, even more futuristic ideas are being discussed, such as installing solar panels in space. Yes, solar panel in space. Yeah.
Actually,
Actually, a fun fact that might seem surprising to you, the first using of solar energy was in spacecraft. The spacecraft Vanguard, the first spacecraft using this solar is Vanguard, was launched in 1950s with the first aircraft satellite with solar panels on it. After too much of publicized failure, Project Vanguard score a bullies on its third fighting at Cap Carnival. The grapefruit size satellite is set into the cone of the three-stage rocket, and the launching route began. The satellite is still is on the orbit. Today, more than 50 British technology organizations such as Airbus, UK Space Energy initiatives have come together to collaborate and create a solar power plants in space. They plan to create a orbit power plant. You know what? If you put the solar panel in the orbit, you will not have to face that dust or cloud, right? It
right.
will directly come from the sun. So no problem, right? No shadow, nothing. So the plan to create an orbit power plant, and similar to how other satellites orbits the Earth, they intend to set up so many solar panels, so that's the solar energy produced can be beamed down on the Earth to be used. Wow, we have to then, okay, we put it in the solar in the space, then how we will get that energy? We have to beam it down, like they are saying. So they will try to use microwaves to beam the energy to Earth to be used there. Several problems that exist on Earth, such as night, rain, clouds, dust, are no exist in space. So it is estimated that the solar systems that install in space will produce 13 times the energy that it can on Earth. So they plan to make it literally by 2035. By 2035 year, like it is 2022, right? 2035 we will get it, but time will tell you how possible it can be. That's all for today's lecture. I hope you like it. If you like it, share it and share with your friends and family. And if you are interested, you can write a comment sections. We have few solar power providers, solar panel installation provider. We will help you on that also. So thanks for watching and keep watching. Bye bye.